So this is lesson 7 on finding the length of a side given one side and an angle of our right triangle. So we're still using SOHCAHTOA. Again, hopefully we know that this is just like a little word to help you remember the trig functions. So sine equals opposite over hypotenuse, or sine of x, I should say. The ka means cosine of x equals the ratio of adjacent side over the hypotenuse of a triangle. And toa stands for tan of x equals OA, opposite over adjacent sides. So these are the ratios that I keep talking about. These are the ratio of sides of a right triangle, and these are the 3 functions that we're using. Ratio of sides are the ones circled. Our functions are sine x, sine, cosine, and tangent. Okay, and we did, when we were finding our angle, let's say we were using sine, we learned that if we want to find the angle, we would take the inverse function, so it looked like this, of the ratio to get our degree measure. So now we're going to stray from angles for a little bit and focus on finding a side length. So this lesson and the practice for lesson 8 is on finding side lengths. It's the same PDF or worksheet, so you guys can get ahead if you want, but this is the video instruction for lesson 7, and then I'll show you the practice for lesson 8 tomorrow. All right, so preliminary information is just information you should know ahead of time. SOHCAHTOA is an acronym to represent the following 3 trigonometric ratios or formulas. So again, I just explained these and they're up top here. So we're going to talk through the model problems, and this is where you're going to fill in information on your sheet as you listen and watch. So example 1, consider right triangle DEF pictured at the right. We know one acute angle and one side, and our goal is to determine the length of the unknown side x, okay? So instead of having an angle we're finding, because we're given the 2 angles, which means we know this third one, we're now finding a side length, all right? So here is one side that we're given, and here's the angle measure that we're given. So step 1 says place your finger on the 38-degree angle, the acute angle, right? Acute just means less than 90 degrees. All right, and then label the 3 sides. The hypotenuse is always the longest side, so that's the over here. It's also opposite from that right angle. The side you are not touching is the opposite leg. So the again, if we're looking at the angle and my finger's here, the side opposite from this angle is across. So here's opposite, and the one adjacent means next to. Or sometimes I say it's touching the angle. So my angle's here, the side touching or laying on the angle is this side, which is the 28 meters, okay? Step 2, so we labeled our triangle. So step 1 was label triangle. Step 2, we need to determine which trigonometric ratio to use. The sine, the cosine, or tangent. It's recommended you write SOHCAHTOA on your paper to help you see which one. So step 3 says ask yourself, which side do I know? All right, so which side do we have or what side do we know? Well, we know this side, right? We're given the 20 meters, which they explain here. Underline both the A's in SOHCAHTOA to indicate that we know the adjacent. So they're saying, all right, put an underline under A. We know the adjacent side. We got to figure out now, we don't have enough information yet. So let's go to step 4. Step 4 says, now ask yourself, which side do I want to find out? So looking at my triangle, in other words, which side length are we being asked to calculate? In this example, we are being asked to calculate the side marked X. So if we look at my triangle, we're trying to find this side. So what did we label X? We labeled it the opposite, right? It's opposite from the angle given. So now we have O and A. So they underlined it for you, but I'm just going to do it again. So which trig function is being satisfied here? Which two letters are being highlighted? Is it OH, AH, or OA? So consider the following. Step 5, considering the ratios and the stuff we underlined. The one we're going to be using is TOA, right? We have both O and A. So we're going to use tan of the theta equals opposite over adjacent. So we've done this before. This is what we're using. Since we know what we're given and we know what we're finding out. Those are the two things you need. So now step 6 says substitute the known information. So we know the angle now. So we used to not know the angle. So we know the angle is 38 degrees, right, from my triangle. We know the opposite is x, and we know the adjacent is 28. So all we're doing is substituting tan of x, or tan of the angle of 38, equals x over 28. Okay, note that we dropped the units in meters for simplicity. We can always add them back later. Step 7 says solve for x. So this is where the math, think about it. You have like this fraction here. So how do you get rid of a denominator on this side? What's the opposite of division? Multiplication. So we're going to multiply the 28 to both sides. So that what happens when you do 28 divided by 28, or when you multiply it by the denominator, they cross out to get 1. The 28, you have to do it to both sides. So multiply 28 to both sides. All right. We get x equals, so we're left with x equals 28 times the tan of 38. So I would do these separately in your calculator and make sure your calculator is in degree mode. Okay, and I've written a lot of directions on how to get there. You go to mode, and you want to make sure it's not on radian, it's on degree. It's like the third row on your calculator. Okay, if you're using an online one, then you may not have to do that. All right, so we're left with simplify. So tan of 38 is this decimal if you put it in the calculator. And then you multiply that by 28 to get the value of x. So this is, we just solved, remember, for a side length. Okay, so we have that. And then our last step was check for reasonableness. So could that make sense? In this case, the acute angle was 38, which is less than 45. If it had a 45-degree angle, both lengths would be congruent. So this is reasonable. Okay. So that's a walkthrough of the example 1 of the model 1. Example 2 is also modeled for you right here on the same PDF. So the same steps, just a different function. They're using sine, but it's the same steps. So it's another model to look at. And model 3, it's the same thing. So this is a lot of great work to look over. And then, so you're stopping here for lesson 7 for review. The lesson 7 was really just like the first model review and doing one of them by yourself, which I think was example 2. So you can walk through those steps because it's already done for you. I just want you to take notes. The lesson 8, which will be due Tuesday at 11:59, but it's also posted so you can get ahead if you want, are these practice problems. And I will post a video of me doing some of them tomorrow. So tomorrow I'll do 1, 4, and 8 for you, and then you guys will do the rest, and I'll be due Tuesday. You can get ahead if you think this is this is self-explanatory for yourself, or you can wait till tomorrow for me to post the next video.